the question is, the energy meter makes 640 revolutions when connected to a load of 50 amperes at 230 volts and 0.6 power factor for an hour. The meter constant is 100. Calculate the percentage error. Right. So he is given a load data which consisting of the details of the current and the power factor and the voltage. So that means we can get the power here. Okay, now this much amount of the power the load is consumed, and that power is given by the power consumed by the load is given by VI cos phi. VI cos phi. So from this we get V is 230 volts, that is given here at 230 volts, and also the current is given here, that is 50 amperes, and the power factor, that is given the 0.6 PF. Right. So this is the information he is given here. So this is the load data he is given. So from this we can find out what is the actual power consumed by the load, and the actual power consumed by the load is 6.9 kilowatts. If you solve this, we will get 6.9 kilowatt. But the thing is, here he is given the meter constant, and the meter constant, what is the formula for meter constant? The meter constant is nothing but revolutions per kilowatt hour. Right. So the revolution per kilowatt hour. Now he is also given, so if this much amount of the power what we calculated here is consumed by the load for 1 hour, if this much amount of the power is consumed by the load per 1 hour, then how many revolutions is the meter is making? 650 revolutions. That means the meter making 650 revolutions with this much amount of the power for 1 hour. So the total energy consumed is the power multiplied by the time. Here how many hours of the time? Only 1 hour. So that's why the energy is equal to 6.9 multiplied by 1. So I can say directly some 6.9 kilowatt hours. So this is the energy consumed. Right. And also we know that the meter constant is 100. Right. So that is revolutions per kilowatt hours. So from this we can find out the actual number of revolution that has to rotate the meter. Okay, that has to rotate by the meter from this formula. So the revolutions equals the meter constants multiplied by the total energy consumed. So this is 6.9 multiplied by 100. That means 690 revolutions. So actually the meter has to rotate 690 revolutions. The meter has to rotate 690 revolutions actually. The meter has to rotate 690 revolutions actually. But how many revolutions does the meter is making? 650 revolutions only. So that's why the meter is running slow or fast. The meter is running slow. Actually it has to make 690 revolutions as per the schedule, but it is making 650 revolutions only. So the consumer will get benefit here, but not the supply company, because he is consuming more power, but the recorded power is for 650 only, but actual revolutions made by the meter is 690, but actual recorded is 650 only. So that's why the meter is running slow. Right. So that's why we can go for the meter is running slow. Only one option is there, that is option B. So option B is indicate that the meter is running slow. So that's why directly we can go for this option. Anyway, we will solve what is the percentage error. The percentage error is given by percentage error equals 650 minus 690 by 690. So from this we will get 5.79%, but this is low because actual revolutions it has to make is 690, but it is actually making 650 revolutions. So that's why we have to go for option B here. Question is here, the sensitivity of a certain meter is 50,000 ohms per volts. So the current required to deflect the meter of full scale will be. So here is asking for the full scale value of the current so that it will be declared to the maximum value of the reading. So first we have to know the relationship between the what is sensitivity and what is the full scale. And we know that the sensitivity of any instrument is given by S, that is equal to 1 by IFS. IFS is the full scale current. That means what? If you circulate this much amount of the current, the meter will read full scale value of the full scale. That the meter will read full scale. The meter will indicate the maximum count, or I can say maximum value of the current. So from this equation, I can write IFS equals 1 by S, where S is the sensitivity. So from this, if you substitute sensitivity here, 1 by 50,000. So from this we can get 1 by 50,000 is nothing but, so this is 1 by 20 microamperes. 20 microamperes. That means if you send this much amount of the current through the meter, so the meter will indicate maximum reading, that is the full scale reading. The maximum reading is also nothing but the full scale reading of a instrument. So that's why we have to go for option A here, right? We have to go for option A.
The question is find the value of A matrix in x dot equal to Ax for the system described by the differential equation y double dash plus 2y dash plus 3y equal to 0. So usually the people will confuse that here. So y indicates the output. So if you take y as an output, so you will end up with the wrong solutions. So here y indicate a state. It is a state. It indicates a state of a system. So basically it's a control system problem. So we have to define what is the matrix A here. So the first of all we have to define what is matrix A here. The A is a state matrix, so we have to find out the matrix A here, right? So with the help of the given differential equations, right? So here, so for convenient purpose I am taking y equal to x1. So if we take y equal to x1, what is y dot? So obviously it will be x1 dot. So we know that x1 dot equal to x2, that is the next state, right? So x1 dot equal to x2, and if I take y double dot, what is the meaning of this? This will be x2 double dot, and don't go for x3, right? So because here the network is consisting only two states, so that's why, so we are limited up to x2. So now I am substituting these things in our given differential equation. So what is our given differential equation? Y double dot plus 2y dot plus 3y equal to 0. Now so try to substitute these things in the given differential equation. So if you substitute these things in the given differential equation, then we will get x2 double dot plus 2x1 dot 2x1 dot. X1 dot is nothing but x2, so 2x2. I am substituting not x1 dot, I am substituting just x2 because y dot equal to x2 plus 3x1 equal to 0. So from this what you will get? X2 double dot equals minus 3x1 minus 2x2, right? This is our equation number 1, right? So we are here the system having two states, so that's why we require two state equations for defining the state matrix. So one more equation is this one. This is x2 dot, simply x2 dot, simply x2 dot. This is y double dot is nothing but x2 dot, right? Y double dot, this is, so x1 dot equal, we know that x1 dot equal to x2 from this equation, so that is equal to x2, right? So I can write this equal to 0x1 plus 1x2. So from this you can write a state equation x1 dot and x2 dot, that is equal to some matrix multiplied by x1 x2. So this is our state equation. So x1 dot equal to what? 0x1 plus x1 1x2, so that's why 0 1, and x2 dot equal to what? So x2, this is x2 dot, x2 dot equal to what? Minus 3x1 minus 2x2, so minus 3x1 and minus 2x2. So the state equation is here, the state equation A is 0 1 minus 3 and minus 2. So this is our state equation, and A is a state matrix. So now A is a state matrix, so we have to go for option A.